was given in the previous question, we know that the total volume of the water that we have to treat a rectangular settling tank without mechanical equipment is to treat 1.8 million liters per day. So we know that we have first initially we have to find out the capacity of the tank. So the question that was asked is find out the width of basin. Width of the basin we have to find out. So first we have to know the cross sectional area of the tank. Cross sectional area of the tank is equal to capacity of tank divided by length of the tank. Length of the tank we know from the previous question, that is 19.2 meters, that we know. So we have to find out the capacity of tank. Capacity of tank we have to find out. How we are going to find out? So total supply of water is to be treated is 1.8 into 10 to the power 6 liters per day. Okay, supply of water to be treated during a detention period of 4 hours. So per day is, we will convert into hours, 4 hours, that is equal to 0.3 into 10 to the power 6 liters, that is equal to 300 meter cube. So capacity of the tank, we can say it as 300 cubic meters. Therefore we can find out the cross sectional area of the tank, 300 divided by 19.2, that will give you 15.63 square meters area has to be provided. In this thing, from the data that was given in the question, the depth of water and sedimentation, water plus sedimentation depth is equal to 4.2 meters, an allowance of 1.2 meter for sediment depth, maximum depth of sediment that can be allowed in this tank is 1.2 meter. So the water depth is equal to 3 meters. So cross sectional area width into depth is equal to 15.63 square meter. By substituting depth of 3 meters in this equation 1, we will get width is equal to 5.21 meters. That is option A is correct. Question is, all vehicles have a average length of 6.1 meters. Average length of the vehicle is given as L is given as 6.1 meter. Average reaction time T is 2.5 seconds. The longitudinal coefficient of friction F is given as 0.35. There is no gradient in the pavement. What will be the average center to center spacing of the vehicle if the speed of the vehicle is 60 kmph? So speed of the vehicle is given as 60 kmph. So the minimum spacing gap that can be provided is 0.278 Vt. V is in kmph. So the average center to center spacing, we are calculating the average center to center spacing is equal to minimum spacing Sg plus average length of the vehicle, that is equal to 0.278 into 60 into 2.5 seconds plus L is 6.1, that is equal to 47.8 meters. So option B is correct. We have to find out the basic capacity of the traffic lane per hour. So we know the basic capacity is equal to 1000 into speed of the vehicle divided by the spacing, average center to center spacing of vehicles. So from the previous question, we know that average center to center spacing of the vehicle is 47.8 meters. And the data that was given in the above problem, vehicle speed is 60 km/h. By substituting these two values in the equation, capacity is equal to 1000 into 60 by 47.8, that is equal to 1255 per hour. So option D is correct. Question is, a beam of 7 meter effective span, L is equal to effective span, that is equal to 7 meters, that is equal to 7000 millimeters, carries a uniformly distributed load of 20 Newton per millimeter, including its own weight. So self weight is also included in it. So W is equal to 20 Newton per millimeter square is given. Allowable stress according to IS 800 is given as 165 Newton per millimeter square. So what we have to find out, the maximum bending moment. So maximum bending moment, maximum is equal to WL square by 8, that is equal to 27,000 square by 8, that is equal to 1225 into 10 to the power of 5 Newton millimeter. So option A is correct. Problem, we know that the allowable bending stress is given as 160 Newton per millimeter square. We know the maximum bending moment, M max is 12 to 5 into 10 to the power of 5 Newton millimeter from the previous question. So what we have to find, the sectional modulus in this question. So section modulus J we have to find out. Z, let me say. So we know the relationship M max by section modulus is equal to FB is the bending stress, allowable bending stress. So Z is equal to F M max divided by FB. M max is 1225 into 10 to the power of 5 divided by 160, that is equal to 7.24 into 10 to the power of 5 millimeter cube. So option B is correct.